Hi folks, welcome back to my channel. It's been a long time. Today we have a fun project. I think it's fun project to build together. So what you're seeing here is a 3D slideshow. It doesn't look like a slideshow, right? Because we inside of a scene, and in the scene we can rotate around. We can interact with the camera in some sense. It has some information. It doesn't have to be Tesla. It doesn't have to be the Cybertruck. It's just some model with some information about that model. And we have the arrows. So when we click on this arrow, camera zoom out and then zooms back in into the next slide. And we have the same experience here with different model, different color. So this is what we're going to build today. And disclaimer, this is 100% complete port from a YouTube video that I found from Wawa Sensei, which is a phenomenal, outstanding React 3 fiber developer and content creator. So make sure to follow him if you're into 3D stuff. It doesn't have to be React, just 3D Blender stuff. So make sure to give him a subscribe. So I saw this video, 3D slideshow with React 3 fiber from Wawa Sensei, and I thought to myself, well, Angular 3 must be able to do that. And here is this video showing that we kind of like replicate what Wawa Sensei builds using React 3 fiber, but we're going to use Angular 3 for it. And this is to say that I will not try to explain the underlying 3D logic of what's working and how it works. So I will highly recommend checking out Wawa Sensei's video on this one, which I'm gonna link in the description box down below. So give that a watch. So what's gonna happen in this video? I'll walk you guys through everything from setting up a new Angular 3 project to finishing the Slideshow project. I will keep it as raw as possible because I hate editing videos, but that also means that the video is gonna get quite long. So apologize in advance and bear with me. Last but not least, I usually don't say this, but I wanna kind of like use this video, like the purpose of this video is so I've been having some personal issues, some anxiety issue with personal life things, work things, kind of like affecting each other, and it kind of stresses me out. So I need like a creative outlet, even though I'm not creative. I literally copy things from React 3 fiber here, but I kind of like need an outlet to let all of this stress out. So this video is kind of like one of those. I want to share my progress on Angular 3 as well. I want to bring something phenomenal from the React ecosystem like React 3 fiber to the Angular ecosystem. And I'm proud to say, to this point, I'm proud to say that it is pretty close. The experience is pretty close. And the developer experience for Angular developers specifically is pretty, in my mind, is pretty good. So I want to share that through this video as well. All right, with that in mind, sit back, follow along if you like, and enjoy the video with me. Okay, all right, so let's get started. That's fine. All right, so what I have here is a brand new Angular CLI project, which I adjusted something. First of all, let's go through the chain. We have Tailwind set up with some Google fonts. Right, you can pick any fonts you like. And then inside of style CSS, we set up Tailwind, pretty standard. Inside of package.json. So in package.json, we install some dependencies, some required dependencies for this project. The first one is Angular 3 and Angular 3 Sober, and make sure you install it using the beta tag. So Angular 3 add beta to get the latest beta version. We also need ng extension because Angular 3 relies on ng extension. We're gonna need 3, of course. We're gonna need 3 standard library, which Angular 3 Sober depends on. Also monogrid getMap.js. You can just grab the latest version of all of these, except for Angular 3 and Angular 3 Sober, which is beta version. For dev dependencies, you need Tailwind, Port CSS, auto prefixer. I just go through the getting started guide on Tailwind CSS for Angular. I added some prettier configuration because I need prettier. And then last but not least, we need the type definition of 3. Of course, again, you can grab the latest version as well. But if you watch this video way later, like you get to like 168 version 0.168, 169 of 3, downgraded a little bit to 166. And make sure if you get to that point, make sure all of these version is kind of like pinned as well, so you don't get different result. Next is we have some assets as well. So we have the fonts assets and we have the models assets. So for the slides, each slide is a scene, is like a pre-built scene, which is built by Wawa Sensei, by the way. I did not build any of these. I literally copy over 100%. We are set up for the config. We use zoneless change detection because why not, right? For app component, right now we just say hello. And we can actually start the project now. So I'm going to start the project. Go back here, go to localhost 4200, and we see hello. Right. I also set up some state. So for the state, we need a scenes array. This is kind of like the hardcode scenes array with 3 scenes for the 3 slides, with a path to the model, to the assets, and each scene is gonna have its own main color. So when you're inside of a scene, right, you see like the background color, kind of like the lighting a little bit. So this it is driven by this main color property. Has some type, and then we have a signal for the active slide. All right. So once again, I would pause here. And go watch Wawa Sensei for the explanation of what we're building, and then we get back here. All right. So I'll see you in a little bit. So what we want is we want to have like a scene component. So this is going to be a scene component. You can call this whatever you want. You can call it scene graph as well, if that makes more sense to you. I'm going to call it scene graph, actually. This component doesn't have a selector, but it needs to be standalone. We need a template, and we need the schemas, custom element schema. So at this point, if you don't know, Angular 3 is a custom renderer, so we work with custom elements, technically. So we need this custom element schema so that the Angular compiler doesn't yell. When custom elements, mention of custom elements, there's one more thing that you need. There's a web types here, property here in package.json. So if you follow along and you use JetBrains IDE, WebStorm, IntelliJ, whatever you have, then you can add a web types property to the package.json of the project, and you point to a web types JSON file, which Angular 3 provides one. This provides intelligence, some sense of intelligence of the custom elements to the IDE. Now, if you're using VS Code, there's a VS Code HTML metadata JSON right here. So you go to HTML in Visual Studio Code. There's an HTML custom data. So just read on HTML custom data and how to set it up, and then point to a metadata.json file on the same Angular 3 directory. So no modules Angular 3 metadata.json file that provides kind of like the same level of intelligence to VS Code. All right, so now back to project. So with that out of the way, so we have the scene. And the way that the way that scene works, or scene graph works in Angular 3 is that we work with custom elements, and the custom elements catalog needs to be extended from somewhere. And we're working with Three.js specifically, so we're gonna extend 3 library. And I'm gonna extend the entirety of 3. You can extend like a granular thing, like mesh, basic material, things like that. But I'm gonna just extend the entire 3, and we're gonna import this from 3. So now we have the catalog extended, which means that we can do ngT mesh, ngT box geometry. You see though, when you type in ngT and then IntelliJ kind of like suggests things from Angular 3, these are from the web types. And before we move on, I'm gonna add like the ngTs orbit controls from Angular 3 Soba as well. I'm gonna save. I'm gonna go back to my app component. I'm gonna use the ngT canvas. So this is the entry point of Angular 3 project, and you can see that we need the scene graph input. Well, we have a scene graph, right? So instead of rendering the scene graph component like a regular Angular component on the template, we're gonna pass this to the ngT canvas, and the ngT canvas is gonna render this using the custom renderer. So it's gonna be a scene graph input, and just say scene, and let's see. And you can see the scene. You can see that cube right around here. It's small though. This is because the ngT canvas takes up the dimension of the parent container, which is right now the app component. So we're gonna use Tailwind to kind of like give this some dimension. For this project, we're gonna take up the entire full screen width and height of the screen. So we're gonna do block, it's screen and screen. And now we have the canvas takes up the whole screen. Great. For the canvas property, I'm gonna set up some property as well. So for the shadows, we're gonna turn on shadows, and for the camera, we're gonna say the position of the camera, the inertial position is 005. So we see this. If I put 000, you will not see the cube. This is because the camera is at the center of the scene, which is at the same position of that cube. So the camera is inside the cube right now. We cannot see it. So I'm gonna move it back a little bit, 5, right? And then the field of view with like 30, so it's a little bit close. We can increase this to like 100. You can see the cube is a little bit farther. So this is the field of view of the bring back to 30. All right, so that's the canvas setup. We'll go back to our scene. Now I'm gonna reference the finished code. So I'm gonna start putting in element, and you can see that how it looks like and how Angular 3 manipulates or interacts with the 3D scenes graph. So first, we're gonna set up the background color for the screen using the ngtrs directive. And for this one, we're gonna use this kind of like gray color, and we're gonna attach this to the background of the scene. So it becomes a little bit gray, right? If it changes to like more red, you can see this kind of like orange-ish. So that's the background color. We need some lighting, so it's gonna be ambient light with this. WebStorm or IntelliJ is awesome. We can do this. All right. Next, we add some environment to this one. So I'm gonna do ngts environment. And for the options, we're gonna say, the preset is CD. You're not gonna see any difference, but if I put an ngT mesh standard material for the mesh, you will see is a little bit different now, because now we kind of have like the dimensionality of this cube with some default lighting, you must say. So I can also do background too, and you see is now have the background, right? We're not going to do that for this project, so we're going to turn off the background. All right. I guess probably this you wondering what is NGTS and what is NGT. So NGTs are things that are made available through extend or extending the catalog, like we did right here. So everything that you extend kind of have the prefix of NGT. NGTS is from Angular-3 Soba. And Angular-3 Soba is a collection of utilities and abstractions for Angular-3. So instead of like setting up the environment map or the default lighting, things like that, the NGTS environment takes care of all of that for you with some sort of preset. Same thing with orbit controls. You can just drop the orbit controls component onto your scenes graph, and then you can take over the camera like this, right? Without doing much. So those are the abstractions that you can just drop in. All right. All right. Now we're gonna move on a little bit, and we're gonna build the main world, the main scene for this project. Now back. I hope at this point you already watched some if not full, of Wawa Sensei's video, and you kind of know what's going on, what we're building when I say main world, right? So the scenes, the slideshows are actually rendered kind of like in like an off-screen buffer, and then we project those like off-screen buffers onto a plane as the texture of the plane. And we manipulate the camera when we zoom in a scene in a way that it feels like we inside of that scene, but actually we just inside of the texture of the plane, which is rendered elsewhere using the concept of portal. All right. So with that in mind, all I want to say is that we have some scenes rendered outside on like an off-screen buffer, right? And then we have some main scenes. So if you look back at the demo, right? When you look back at the demo, when we move out, we see some objects up here. So those are part of the main scene. Also the grid as well. So that's part of the main scene, which we rendered right now. Right, so go back to our project. I'm gonna say an NGT group. Inside of this group, we're gonna have a mesh with precision of 0, viewport dot height divided by 2 plus 1.5, and then 0. And for this one, we're going to use torus geometry with the R's of 0.75 and mass standard material. Well, we're going to render a torus donut at this position. Where viewport come from? Well, funny you ask. Angular-3 keeps tracks of the canvas state inside of an injection token called store. But Angular-3 provides like an inject function for that. So you can do private store inject store. And inject store is from Angular-3. On the store, now you can grab the viewport from this store.select viewport. The viewport is what the camera is seeing. That is the viewport. It is also a signal, which means that it is reactive to resize. So when I resize, you can see that the camera reacts to the resize event, and the viewport changes. So that is the viewport. And on the viewport, we have height, we have width, top, down, bottom, left, and things like that. And we can use that to set the position for this mesh. And we will zoom out, we see that is the torus. Right, we want to change this torus color to the color of our scenes, the first scene, main color. And we're just gonna move this up here. Oh, where is it? Save. And now we are actually have the scene. I mean the torus with that color. We're gonna do it 2 more times for 2 more objects. Right, and for the second one, we want to move this to the right of the first one, some distance, and the distance will be the viewport, the entirety of the viewport, plus the distance between the slide. And for the distance between the slide, I'm gonna just say it's gonna be read only right now. For now, slide distance is gonna be 1, and for the width it's gonna be viewport width plus slide distance. It's gonna be the same thing for this one, but we times 2 on this one, and we save this one, and you can see that now we have 3 objects spaced evenly with the viewport. So now for the second one, we're gonna use just the box, right? And we don't need this anymore. And we're gonna use the second scene color. And for the third object, we're gonna use this geometry. Of course, we don't need the R's, but we're gonna use the third scene color. And now we have these 3 objects. Pretty cool. All right. What next is that I want to show you how to participate in the animation loop of the scene. What do I mean by animation loop? You don't see it right now. It is not visible, but the entity canvas actually set up in a running animation loop right now on every frame, which you can customize, but the default is that it will render every frame. Well, how do we prove that there's an animation loop going? So as I move the camera around, you can see that, right? This is the NGTS object controls component. If I flick the mouse really quick from one direction to another, like this, like that, you can kind of see the camera slows down and then stops instead of stopping right away. In that moment, when it slows down and then it stops, right, it's not being controlled by any kind of like mouse event, right? But that keeps going thanks to the animation loop that changing the camera position little by little. So that's thanks to the animation loop. And the NGTS object controls kind of like have that built in. We can disable that though, but I'm gonna keep it as the default. So now we want to kind of like animate these 3 objects. Okay, let's just spin them around. How do we do that? How do we grab the reference to these objects? Well, in Angular, you would grab the reference to this object using template variable. And we're going to do the same thing here. We're going to say this is the torus, this is the box, and this is the whatever that is. All right, so we have those 3 template variables. We can use viewChild to grab those, right? So it's box, it could be viewChild.require box, and this is going to be an element ref of mesh. So it's not HTML, it's actually 3D object, 3JS entities. And this is thanks to the Angular-3, custom renderer. So we have the box, we have this one, we have the torus as well. So we have these 3 signal queries, which now go to the constructor, inject the before render, custom inject function. This allows you, accepts a callback. This allows you to participate in the animation loop using this callback. Right. So inside of here, we're gonna grab those three objects. You should you should know this. I don't have to explain this part if you're like an Angular developer, right? So we just grab those element ref native element, which is gonna change soon. So check out the RFC on the DOM ref. We have this, and we have the torus, and we just use whatever Copilot gives us. So in here we're saying, oh, this is way too fast. Copilot, this is way too fast, man. We're gonna grab this to that. So this is saying that for every frame, rotate these objects on the y-axis by 0.01. And the effect of this is that we have this kind of like effect of spinning slowly, rotating slowly, like objects. So this is how you would participate in the animation loop. Well, grab the reference using viewchild, very familiar, and then just reference them in this inject before render and change things as you like. Right, so we have the objects, and the last thing we're gonna need from this is the grid. Here we're gonna do the grid, and the grid is again an ngts component, so we need to import it and save, and you will see that we have a grid on the floor. It's kind of like, oh, it's the floor, right? It's the floor. Next is we're gonna loop over our scenes, and we render 3 planes. The planes are gonna be used to kind of like have the scenes, the actual scenes projected onto them. So what we're gonna do is we're gonna use for control flow is a scene of scenes, and we're gonna track by the scene name right there. So for each scene, we're gonna render a plane, right? So ngT mesh for the precision, we're gonna say it's gonna be the index times the viewport width, pretty similar to the object, plus slide distance, and that's it. And then we have the plane geometry. Plane geometry with the dimension of the viewport. So it's going to be viewport.width, viewport.height. And if when I save this one, actually let's text out the, we'll save this. Is this right? It does not look right. Oh, we need to wrap this in parentheses. There we go. So when I save this one, you can see that the first plane kind of like takes up the entire screen, but if I zoom out, we can kind of have that set up right here. So we're gonna render the scenes, right, on an off-screen buffer, and then we project those screens onto this plane. And to project it, we're gonna need a material here, and we're gonna put something here. Right, and we need to set a tone map to false. There we go. All right. So the next thing we want to do is we want to just render those scenes, and we're gonna create a new component called render texture scene .ts. For class render texture scene, it's gonna be a component with a selector, render texture scene standalone, to template. Then of course we need the schema of custom element schema, and let's do chain detection on push. So as far as the input goes, we need the required input, like a required input of this actual scene. So we could do the scene of input dot required, and the type will be the showroom scene. So that's our type. Next, we're gonna grab the name out of the scene signal, right? You can do compute it if you like, but I'm tired of writing or typing parentheses, so I kind of like have these little helper instead of Angular-3 that you can use to pick, create like compute it, but you can do like less parentheses. So say, hey, pick from this signal object the name property, and it gives you the name computed signal. So now we have the name. We're gonna load this model. Actually, we have the scene. We can now load the model, and the model is actually on the path property. So on the scene, there's a path property. We're gonna use that path to load the model. I'm gonna call this a GLTF, and we have an inject GLTF from Angular-3 solver. Give us a function or a signal to the path. So it's gonna be this. That's it. This is how you would load that model, and this returns a signal of model or no, right? Signal will always have an initial value, and for these external assets loading kind of scenario, no is the default value. Next, we're gonna just extract the model out of this GLTF file. Now, GLTF contains more information than just the model itself, maybe like some animations, right? So we're gonna use the computer this time, and we'll say track GLTF. Track the dependency, the GLTF signal. If we don't have it, return no. If we do have it, it's gonna be the scene property. We return it, but then before we return it, we're gonna traverse over the child, over basically the model, and if it is mesh, then we're going to turn on cast shadow and the receive shadow. Basically, turn on shadows for the objects. So now we have the model, which is a signal of group or no, and we can actually render this model. Even if I put things here, you won't see it because, as I mentioned, we're gonna render this on an off-screen buffer. So let's do that. Actually, let's just render it. You know what? Let's render. So I'm gonna say this is gonna be a primitive. It's the arts. Primitive is a special element. It's gonna accept a pre-built 3D object. So it's gonna accept a pre-built 3D object, and you can pass it in that pre-built object, and this pre-built object will text over the node on the template for you. So that's the NGT primitive. So even though we say NGT primitive here, right, and when we reference it, this reference is gonna reference this scenes right here. So that's just basically how it works. And this is gonna have a scale. I'm gonna grab from over here the ratio scale of something like, someone say protected ratio scale. All right, and I'm gonna use this to say, hey, parameters scale ratio scale. And because we're rendering this as a off-screen buffer, on an off-screen buffer, this needs its own camera. So I'm gonna use NTT group right here. Put this inside of this group. For this one, I'm gonna say dispose null and just give it the name, right? So we have that name signal. Inside of this group, we're going to do the perspective camera. And we're going to say, make this the default camera for the off-screen scene. And turn this to true. Set the position to 3, 3, and 8. And the near is 0.5. So we have this. All right, so we have this. What we need now is some lighting, because actually let's just render it. Let's render it. So on the main scene, so right here we can do ngts render texture, right? And inside of this, we're going to render our render texture scene. But we need something. We need the directive of render texture content. And of course, we need to pass in the scene. This is save. And that is our scene, but it's all black because we need some lighting. Let's go back to the scene and let's put some lighting in here. So it's going to be ambient light. Well, that works. I'm gonna import the math here, bring it up here, save, and now you can kind of see it. It's right there, right? You can kind of see it. Precision is a little bit off though, but you can kind of see it. All right. So next is to finish this off-screen buffer. So as we work on it, you will see it starts kind of like becoming more lively. So we need the NGT orbit control, because remember, when we inside of this scene, we can control the camera, right? So we need an NGT orbit controls with some option. It's gonna be auto rotate set to 2. Enable pan. We don't want them to pan around. We need the max power. This is gonna be from here. I kind of want to see how it imported. Well, that's not gonna work. It's gonna be from math util. That max polar angle is that one. Min distance is this. We have the max distance and the speed. So we're gonna save this. Kind of see that that's the scene, right? Next is some lighting. We have the ambient light, but it's not enough. We need some shadows. Inside of this accumulative shadow, we have some randomized light. This needs some options as well. That is the option, I believe. Yeah. And for the randomized, yeah, you can kind of see it. For the randomized lights, we need this. Is this what it is? No, that's not. That's not it. I'm gonna copy this over. Just drop that in. There we go. Gotta see it coming. And now we're gonna set up the environment. So it's gonna be environment. We'd want this environment to have an options of blur 0.8, background 2, and we need the template. So that we're gonna render the object inside of the environment again in as like the environment map. So whatever we put in here will be part of the environment. So we need the mesh scale 15. This is gonna be a sphere geometry. So this will act as the kind of like the word of this environment of this scene. You can kind of see how it works. So for this, we're gonna use the mesh basic material, right? And the side will be back side. Where is it? Right there. So we only render the back side of the sphere. So inside of the sphere, we only render the inside of the sphere. So from outside, we don't see the sphere at all. But when we inside, we will see the sphere. So this gives the effect that we inside of this world. And of course, we need the color, right? and it's just use the scene main color. And I'm gonna save this, and you can kind of see. Haha! It's kind of working. You see that? It's kind of working, right? There you go. All right. Right. So back to this. We need some more light. So for this one, we will use save. Yeah, you can kind of see that there's a red kind of like object reflected on the model there, right? That is the light former. This is, and specifically this one, it is part of the environment. So if I turn off the blur, you will see that object right there, right? So we render these objects so that they are part of the environment, and it looks kind of like more realistic of the environment around them, of the object. Put back the blur, and there will be blurred. And now you can see the reflection, but you don't see the itself. Pretty cool. So this is actually the finished. The render texture scene is actually finished, but now we need a way to kind of like move between these scenes. Move in and move out these scenes. The scene itself, I'm gonna remove this orbit control from this from the top of the scene. So now we are actually using the orbit controls of the inside scene. So this is the inside of the sphere. This is inside of the sphere. So this is kind of cool right here, right? So you're saying, just you can see that we have the material and we want to apply some texture, but that texture is a off-screen scene that we can render pretty much anything. And we can use this to apply the as texture to a material. So this is a very powerful thing from the React 3 fiber ecosystem that they built. I just kind of like port this over to Angular using content projection and some structural directive, but it's working very nicely. So there's that. Right now, so right now what we're missing is we're missing some like camera controls, and I'm gonna create a new component for it. It's gonna be a camera handler TS. This is actually just a directive, I believe. Oh, it's a component. So this component is gonna be using standalone true template that schema, custom element schema, chain detection. This actually doesn't need the custom element schema because we render a component that we know of, which is camera controls option. We're gonna say touch that. That is the options for the camera control. And just paste it here and I'm gonna explain things. So this camera handler takes in the slide distance as an input. Mainly because, so you remember we have the slide distance hard-coded from the main scene component. We can actually control that. We can change the slide distance to change the way that the camera controls work. Of course, we can inject the store as well, so we can get the viewport. We can grab the NGTS camera controls instance with viewchild. And this is auto effect. The way that auto effect works is that this returns an effect function that's automatically has the injector of this component injected. So basically, you can call this auto effect function anywhere without worrying about the injection context because it has the injector injected already. So that's why it's called auto effect. And I want to do auto effect because I want to call this effect inside of the after next render. So basically in the ng on init. So after the first render. So we have slide. Where is the slide come from? Oh, this is the active slide, by the way. So I'm gonna grab all of this. Go back here. Say this is the active slide. right? And that, save. All right, so what happened here? So inside of the after next render, we have two effects. The first effect, basically we based on the viewport to change the camera controls target. And then the second effect is when the active slide change. So when we change slide, we will call move to slide, and we will just reset the last slide to this one. So we call move to slide, and inside of move to slide, we just grab the camera controls from the NGTS camera controls component, and we call set look at on them with the slide information. That's pretty much it. So basically, we move the camera from this slide to the next out to the next slide, out to the next slide. So camera controls is basically just like the orbit controls, but it gives us more function to work with the camera in a nicer way than just giving us the control, the camera control. So now with this in place, we can go back to the main scene and drop in the camera handler, of course, pass in that slide distance, save, and now we have this. Do a set timeout and maybe 1 second, change the slide. There we go. So that's the effect. That's the effect that we're looking for. So maybe change to 1. So 1 second, go to the next one. So our 3D scenes is actually finished. Now we need some overlay, right? And this is just some HTML to display the text and the arrow, and not that. I'm gonna grab slide will be active slide, and scene will be up. Scene will be from this active slide, active slide. So that's our overlay. I actually kind of want to move the state outside because the overlay also uses. So I'm gonna move outside. Camera handler is actually there, bro. What are you talking about? There we go. So with that overlay component, let's see. So we have a div with some like fixed position. So because we're working with canvas, and the canvas takes up the entire scene, right? So we kind of want to have our HTML layer overlay on top of the scene with like fixed or absolute position, so that it is not underneath, but on top as an overlay. We don't want to display this. We control the opacity of this kind of like overlay with visible. This gives like the phase in, phase out, fade in, fade out, kind of like animation feeling when we change from one scene to another. We have some SVG for the arrow. So this one is the previous click, previous arrow, bound to the previous click. This is the next arrow, or the right arrow, bound to next click. And then we have some like more HTML elements to display the name, the description, and more things. This one, and this one is like to locale string. What is it? Yeah, 72,000. You know what? Let's use something that Angular developer has, which is currency, right? I don't even know how it looks with the currency pipe, to be honest with you, which we're gonna find out. So I'm gonna go back to app component. Just drop the app overlay right here. Save. And now we have the overlay. And that is the price with the currency. And now we can click on this and go to the next slide. And we inside the next one. All right. That's it for the video. I hope you have fun. I hope you enjoy it. I know it's long. I don't really care at this point. But I hope that this kind of like brings some new experience to Angular developers. I'm gonna link the repo and everything that you need, the models and stuff like that you can find in the repo in the description as well. All right, bye. See you in the next one.